Good morning, everybody. So, in work and energy chapter, we will proceed with the numericals now based on the prior concept. So, let us start. So, first numerical is force acting on 40 kg mass change its velocity from 5 meter per second to 2 meter per second, and we need to calculate the work done by the. So in this numerical, what is given to us? We are given mass, that is 40 kgs, and to which the force is applied. Initial velocity is given in the numerical, that is 5 meter per second. So what is work done? Work is equal to force into displacement, and we need to calculate displacement and the force required by it. So what is this? First of all, to calculate the value of displacement, we will take the help of the Newton's third equation of motion. What is that? By third equation of motion, what is it? V square is equal to U square plus 2AS, and we will calculate S from here. What will come? V square minus U square upon 2A, that will be value of S. We will take the value of S from here and we will submit it. Okay, that is F multiply V square minus U square upon 2A. And what is the formula of force? Because the exact value of force is not given to us. So what is the formula of force over here? The formula of force will be is mass into acceleration. As we know very well, what is force? That is mass into acceleration. We will use that concept. That will be V square minus U square upon 2A. Here A and A will be cancelled out. So what the value will come? What is the mass value is V square minus U square. And now we will submit the values by taking that was given to us in the question. So what is the mass? That is 40 kg. V square, that is final velocity, that is 2 square minus U square, that is the initial velocity, that is 5 square. So what we will obtain from here? We will obtain 40, 4 minus 25. So what we will get from here? 40 minus of 21, and if we will multiply minus of 21 into 40, the value we will get will be 21 into 4, that will be minus 25, that is minus 240 joules. So this will be our answer. Here we have given this, the work done is negative, means the displacement and the force, they are in opposite direction. So here work done is minus 420 joules, and it is negative work done. The work done is negative over here. Thank you. Now let us proceed with the next numerical that is given to us. A mass of 25 kg is at point A on a table. It is moved to point B. If the line joining A and B is horizontal, what is the work done on the object by the gravitational force? So now what is given to us? A mass of 25 kg is given to us, which is at point A on the table, and it is moved to the point B. Okay, and if the line joining A and B is horizontal, means they are on the same plane, and what is the work done on the object by the gravitational force? Let us proceed with it now. Now according to the question, a mass is given to us, that is 25 kg, which is lying on the table. Okay, and this table is horizontal, and from point A it is moved to point B. Okay, and we need to calculate the work done by force of gravity, that is gravitational force. So now what we are observing from this, that when the force and the displacement, when it will be displaced to point B, the force and the displacement are at 90-degree angle over here. Means what is there? That force of gravity is perpendicular to the displacement. And when this condition happens, the work done is always zero. So here simply the work done will be zero. Work done, that is equal to 0 over here. Thank you. Now let us proceed with the next numerical. What is given in the first numerical? A man has pulled a cart through a 35 meter by applying the force of 300 Newton. Find the work done by the man. So what is given here? That a man, he is pulling a cart. How much he has pulled the cart? That is 35 meter by applying how much force? 300 Newton. And simply we need to calculate the work done by the man. Now here, in this numerical, we are given displacement, that is 35 meter, and how much the man has taken the cart. So distance, the displacement that was covered here, that is 35 meter. Force provided was 300 Newton, and we need to calculate the work done over here. The simple formula of work done we will apply over here, that is work is equal to force into displacement, and that is what force is 300 Newton and displacement is 35 meter. So here 35 into 3 will be 105, so that will be joules. So this will be our work done that we have calculated, and that was work done by the man when he used to displace the cart with 35 meter by applying the force of 300 Newton, and that is 10500 joules. Thank you. Now let us proceed. Suppose a constant force F acting on a body produces a displacement S in the body along the positive x direction. Now what is there? We have taken force F over here, and don't worry that we have used the vector sign over here. You will learn about the vectors and the scalar quantities in the +1 standard. But vector is what? When there is a magnitude also and direction also. And scalar is that quantity where there is only magnitude. So here force is that quantity which has both magnitude as well as direction. And a body produces a displacement. Displacement also has magnitude as well as direction. So we are using vector sign over S in the body along the positive direction. Now what is there? A force is there that is acting constantly on the body, and that is moving in the positive x direction. Positive x direction means like this is the x-axis, y-axis, and this is minus x, and obviously this will be minus y. So we are talking about this positive x direction. And if theta is the angle which force makes with the positive x direction, then the displacement, and the displacement S is there, that the body is moving from A, take it as point A, and you can take this point as B, and the body is displacing from point A to point B. Then this is one of the component of the force. Force can be divided into two components, that is F sin theta and F cos of theta. So we are using the horizontal component over there, that is F cos of theta. So don't get confused. For the sake of little knowledge, you can understand like this. This is one of the component of the force, and the component of the force here is F cos of theta. That is in the direction of the displacement. So it is in the same direction of the displacement. So if theta is the angle which F makes the positive direction, x direction of the displacement, then the component of F in the direction of displacement and magnitude of the displacement will give the work is equal to F cos of theta into S. Right, so we will use the same force, the force which is used in this component and the displacement. So formula becomes here that work is equal to Fs cos of theta. Thank you. Now the horizontally we are dragging the object. Suppose this object is there and we are dragging the object by 8 meter according to the question, and we have applied how much force over there? We have applied 100 Newton force over there. Right. So we are dragging this object horizontally, means here which component will come? Fs cos of theta. So let us proceed with this numerical now. Here force is given to us, that is 100 Newton. Displacement S, you can take it here, that is 8 meter. And now displacement and the force, they are in same direction. Same direction means 0 degree, 90 degree, 180 degree, 270 degree, and again 360 degree. So they are displacing in this direction, means they are going towards which angle? 0 degree over here. So we will use theta equal to 0 degree. Since force and you can take and S, that is displacement, are in same direction. Fine with it? Now we have everything to calculate. Now we need to proceed with the work done. So formula of work done as per the prior concept, that is Fs cos of theta. Right? So F is what? 100 Newton. Displacement is 8 and cos we will take 0 degree over here, and cos 0 is always equivalent to 1, that is 800 into 1. So the answer we will get here, that is 800 joules. The work done here is equivalent to 800 joules. Thank you. Now let us proceed with the third numerical. A body of mass 120 gram is given now. It's given gram. It is 120 gram and it is taken vertically upward to reach the height of 5 meter. We need to calculate the work done over here, and gravity we need to take, acceleration due to gravity we need to take is 10 meter square. 10 meter per second square. Now let us understand the numerical. Now here what is there? A body of mass is there, that is 120 gram, and it is taken vertically upwards, means we are doing the opposite displacement over here against the gravitational force, means force and displacement, they are in opposite direction. So here acceleration due to gravity will be -10 that we will take in this numerical. So let us proceed with it.